Great to see you again in this new video offered to you by the Coster Academy. It's a new chapter in our Math Survival Guide. In this video I'm going to talk again about finding roots of equations, and here we're looking at completing the square of a quadratic equation. Now before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look what we mean with resolving the quadratic equations, finding their roots using the method of completing the square. When we look at a quadratic equation, the general expression is of the form f of x is ax to the square plus bx plus c. And this expression is basically very specific because we can have two roots, x1 and x2. It means that f of x1 is equal to 0 and f of x2 is also equal to 0. I take x1 always as the smallest root and x2 as the largest root. Now we try to find and transform this expression so that we have a complete square. And a complete square is an expression that we can reduce to a plus b to the square, like we've seen in the special products formulas. Now consider the special equation x to the square plus bx equal to c. And when we look at this, we would say that the complete square would be of the form x plus a to the square, which is x squared plus 2ax plus a to the square. And now we have to find, first of all, the first term x to the square. That's okay, that's correct. And we have to find the 2ax, the product here, and with our equation we can say that b is equal to 2 times a, so we can find in the complete square that a is equal to b divided by 2. And the last term, a to the square, is in fact b divided by 2 to the square. So this is the term that is missing in the top equation. So we have to rewrite this equation and we have to add that remaining square. So let's continue with the equation we started with, x squared plus bx is equal to c. And the first step is to say that a is equal to b divided by 2. And we replace this in the equation. So we find x to the square is 2 times b divided by 2 times x plus c. And when we multiply 2 with b over 2, we find b, so we still have the same equation. The next step is adding a to the square, which in this case is b divided by 2 to the square. We have to add it to both sides to keep left and right hand side equal to each other. So we find x to the square plus 2 times b divided by 2 times x plus b divided by 2 to the square is equal to c plus b divided by 2 to the square. We can now add this to the equation, so we put the equation here and we look at the next step. The first thing I do is to replace b divided by 2 to the square by b to the square divided by 4. The next thing we do is take the square root, because now we see that on the left hand side we have a complete square, and that complete square is x plus b over 2 to the square, which is equal to c plus b to the square divided by 4. And now we continue, because now we have this equation, we have a complete square on the left hand side, we have a term on the right hand side, and now we take the square root of the left and the right hand side. It is clear that taking the root means that c plus b to the square divided by 4 has to be positive. The right hand side has to be positive to find a real solution. When we take the square root, of course, we have two possibilities, and we can say that x1 and 2 plus b over 2 is equal to plus minus square root of 4c plus b to the square divided by 4, and we can take 4 square root out of 4 out of this equation and replace it by 2, because 2 is 2 to the square. So we find x1 and x2, the two roots, are equal to minus b plus minus the square root of 4c plus b to the square divided by 2. And that's what we're going to use in the following exercises. This is the first example, our first equation, x to the square plus 4x minus 7 is equal to 0. I move 7 to the right-hand side and I replace 4x by 2 times 4 divided by 2x. So we find x to the square plus 2 times 2x is equal to 7. And we find here that a is equal to 2. And the square component that we're missing, a to the square, is equal to 4. So we add 4 to both sides, and I find on the left-hand side x to the square plus 2 times 2x plus 4 is equal to 7 plus 4, which is equal to 11. And now we can find the roots of this quadratic equation, because we have the complete square x plus 2 to the square is equal to 11. And we take the square root, so we find x1 and x2. x1 and 2 is equal to minus 2 plus minus square root of 11. We find x1, the smallest root, minus 2 minus square root of 11. And x2, the highest root, is minus 2 plus square root of 11. And we see that in this example, we have 2 real roots. Let's have a look at another example. Here we have x to the square plus 3x minus 14 is equal to 0. And we are going to apply the same thing again. Step 1, we rewrite 3x as 2 times 3 halves times x, and we find that a is 3 halves. For step 2, we have to add a to the square. We found that a is equal to 3 halves. This means that a to the square is 9 divided by 4. And we bring that in the equation, so we find the new form of the equation is x to the square plus 2 times 3 halves x plus 9 divided by 4 is equal to 14 plus 9 divided by 4. And we have a complete square on the left-hand side, so we can say x plus 3 halves to the square is equal to 65 divided by 4. So because I completed 14 plus 9 divided by 4, which is basically 65 divided by 4. Now we can take the root of this expression, and we find that we have in this moment that x1 and x2 plus 3 halves is plus minus the square root of 65 divided by 4. We can take out the square root of 4, which is equal to 2, and we can say that x1 and x2 are equal to minus 3 halves plus minus square root of 65 divided by 2, which gives us x1 minus 3 minus square root of 65 divided by 2, and x2 minus 3 plus square root of 65 divided by 4. And that's the solution of the second polynomial. Be careful, because we may find a right-hand side when we have the complete square that may be negative, and in that case we cannot take a square root from a negative number. In that case there is no real solution, and we'll look into that later when we consider complex numbers. Now that was it for this video about finding the roots of a quadratic equation, a quadratic polynomial, using the method of completing the square. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and bye-bye.